So we've seen some of these already in the representations, but let's talk some more about drawing and writing compound inequalities in interval notation, and we'll talk about how to solve them. So this first example here we've kind of seen before. Let's go ahead and start with the graph, and we're going from -1 to +3. So let's go -1, 0, 1, 2, 3. And at -1 we'll have a solid circle. At +3 we'll have a solid circle. We have everything in between. So x is more than or equal to -1 and x is less than or equal to +3. So both of those things are true. And for our interval notation, we're going from -1 to +3, and we're including both of those values. So we'll use square brackets. Okay, with this next one, we're going to see a new term, or. So it can be one or the other, or both. So actually both doesn't quite work here, but that's usually how we use or in mathematics. It's one or the other. So with this, we're looking at x is more than 2 or x is less than or equal to -3. So let's say we have -3 out here, -4, -2, -1, 0, 1, 2, 3. And we'll just label our number line there. So we're going to treat these separately. So x is more than 2. So at 2 we'll have an open circle. And then it can be larger, so we're going to go off to the right-hand side. Or x is less than or equal to -3, so we'll have a solid circle at -3, and then we'll go off to the left-hand side for anything smaller. So we end up with these these separated areas. It could be either over here or over there. Now when we write this in interval notation, we're going to have two separate intervals. We have that x is less than or equal to -3, so we're going from -infinity to -3, and we're including -3, so we'll use a square bracket. And then the symbol that we use is going to look like a big U, stands for union, but it works for replacing this word or. So we're going to have this interval from -infinity to -3, union with 2 to infinity, and we're going to use parentheses with 2 because we're not including it, and then we go off to infinity. So we can combine separated intervals with this union symbol to say it's one or the other. And this next one here is similar to our first case, just combining some different symbols. So let's see, from -3 to 0. And let's number that line there. So at -3, we'll have an open circle. At 0, we'll have a solid circle, and we're stuck in between those two values. Okay, and with our interval notation, we're starting at -3, going to +0. We'll use a parenthesis with -3, square bracket with 0. So there's some of our representations with compound inequalities. Now let's talk about solving. So with these first two cases, what you can see is we have three pieces. We have the smallest value, middle value, largest value. And that can switch during our solving process, but let's just say that for the beginning. Now something to notice with this first case is x is just in the middle there. That's the only spot it is. Whereas the second case, x is all over the place. So with that, we're going to use two different methods here. With this first case, I'm going to keep it just like this. And what I want to do is keep x in the middle. So what I want to do is isolate x in the middle of this compound inequality. So to do that, I'm going to follow my standard steps I usually do so I can isolate x. So first thing I'm going to do is add 6. But now it's not just both sides of the equation, it's like 3 sides of the equation. So we're going to add it on the left-hand side, we're going to add it in the middle, and we're going to add it on the right-hand side. So that's going to mean we have -12 is less than, nope, not -12, sorry. negative 12 plus 6, so negative 6 is less than 3x is less than or equal to 0 plus 6, which is 6. So we just have to make sure we do it in all three spots. And then to get x all alone, I want to divide by 3, and I would need to do that absolutely everywhere. Now, we're dividing, but it's a positive value, so I don't need to worry about switching it. If I was dividing by a negative here, all of the signs would flip. So all symbols would change direction. But that's not the case here. So we'll just have negative 2 is less than x is less than or equal to positive 2. So in terms of a graph, we're going from negative 2 to positive 2 with an open circle at negative 2, closed circle at positive 2, and everything in between. And for our interval notation, negative 2 to positive 2 with parentheses with the negative 2, square bracket with the positive 2. All right. Now, with this one, this would get tricky in terms of following that same thing we did there, because we'd be trying to do too many things at once and just it would get messy. So instead, what we're going to do here is separate this into two scenarios. We have that 7x minus 10 is less than 4 plus 5x, and negative 4 plus 5x is less than negative 6 plus 10x. So what we're going to do is solve these separately, and then we'll combine our results together. But the connection between them is a word and, where they both have to be true. So first case here, 7x minus 10 is less than 4 plus 5x. So let's go ahead and subtract 5x from both sides. Add 10 to both sides. So we're going to have 2x is less than 14. Divide both sides by a positive 2. So x is less than 7. Okay, so x is less than 7. And then over here, 4 plus 5x is less than negative 6 plus 10x. So let's go ahead and subtract 5x from both sides. Add 6 to both sides. So we'll have 10 on the left-hand side is less than 5x. Divide both sides by 5. It's a positive, so we don't need to worry about switching anything around. So we have 2 is less than x. Okay, so x is more than 2 and less than 7. So I could do is combine that back together into the statement 2 less than x less than 7 for my inequality. Which means in terms of a graph, we're stuck between 2 and 7. 2, 3, 4, 5, 6, 7. And we'll be using open circles for everything because we're not including the 2, not including the 7. And those symbols should stay the same. Like, you're not going to suddenly have equality at the beginning and then not have the equals part later. It should always stay the same. So like we had over here on the left-hand side, we started with strictly less than and a less than or equal to. We ended with a strictly less than or equal to. All right. And then for interval notation, we're going from 2 to 7. And we're using parentheses because we don't have the equals. Okay, one more scenario here, and this time it's with the wording or, but our process is going to be the same as what we did up above there. It's just these are likely going to be separated from each other. So, one or the other, we have negative 7x plus 9 is more than negative 5, or x plus 9 is more than or equal to 14. So, on this left-hand side, let's go ahead and subtract 9 from both sides. So we have negative 7x is more than negative 14. And then we're going to divide both sides by negative 7. And we're dividing by a negative, so I need to flip the sign. So I'm going to have x, negative 14 divided by negative 7 is a positive 2, but instead of more than, it's now going to be less than. All right, so x is less than 2, or on this right-hand side, let's subtract 9 from both sides. X is more than or equal to positive 5. So we have x is less than 2, or x is more than or equal to 5. So in terms of a number line, what we'll see is, let's go 1, 2, 3, 4, 5, 6. So x is less than 2, so we'll have an open circle at 2 and then everything's smaller. Or x is more than or equal to 5, so we'll have a solid circle at 5 and then everything above. So our two intervals, we're going to go from negative infinity to positive 2 with parentheses, union with 5 with a square bracket going off to positive infinity. All right, so there's some different scenarios with compound inequalities and how you solve them, but also how we represent the answers, either as an inequality, graph, or interval notation.